All right, so everybody has their notes out. Everyone is ready to go. We are going efficiently and quickly. Of course, not everybody has their notes because two people insist on arriving late every single class and don't have their notes. Those are new. These are new notes. Okay. So, how will you solve your problem? There you go. A system of equations. What, forgetting about math, what is a system in English? What does it mean? Vanessa?
Different components that come together to make something?
Different components that come together to make something happen. Excellent. Now, think of math. If it is a system of equations, what are the components? Equations. Way to use English to solve a math problem. That is absolutely right. Nope. Just the whole equation is what we're looking at. A system of equations is simply a comparison. Nice spelling, Mr. Myers. A comparison between two or more equations which may share a solution. Now, we already know that every equation has a solution, yes? And we know how to find those solutions with algebra, yes? So if I give you an equation, y equals 2x plus 6, can you tell me one solution to that equation? Because how many solutions does that equation have? Infinite. So can somebody tell me one solution? 6. Kind of. That's half a solution. There's an x and a y. Don't I need two numbers? 8 is also half a solution. Again, I need two numbers for a solution. So what's the solution? No. Y equals 10, x equals 2. That is the solution. How do we write that solution in Math 10? Y equals 10, x equals 2. That's a solution. I've told you that's right. How would I write it down? On a table of values, that gives me part of it, but how do I actually write the finished solution? 2, 10. That is the solution. Everybody understand? Now, somebody who said 6, I assume that was because you used 0 and 6. That's what makes a solution. Two parts. Bryce said, no, he said 2 and 10. Somebody said 8. That would be 1 and 8. Right? So these allow us to find a solution algebraically by substituting 2 in for x, 0 in for x, 1 in for x. But they also allow us to find a solution graphically, because I can put those on a graph, connect the line, and what do I know about every single point on the Cartesian plane that that line goes through? That it's going to work in this equation, right? Okay. So a linear equation is what? What is a linear equation? Don't give me an example of it. Tell me what it is. Yeah? Not quite equally, because they don't have to go up by the same amount as each other, but they have to go up by the same amount. Uniformly is the word you're looking for. Okay? So a linear equation is an can, I forgot the N, an equation, does it have to be X and Y though, Vanessa? Right. In math class we use X and Y, but in physics we use distance and time. In biology we use bacteria and time. In socials we use population and years, right? But the skills are all the same, aren't they? They all come from math class. We call it X and Y in math so we can apply it to anything else that we want. So it is an equation where the two variables change by uniform amounts. That's algebra. What does it look like on a graph? Right, graphs as a line. Because we know we're going up and over the same amount every time. Or down and left the same amount every time. Everyone cool? All right, now you guys are smart kids. A linear equation is this. A system compares to equations. So what must a linear system do? Pardon me, Bryce? It's a comparison between what? Two or more linear equations. All right? Now you guys again are smart kids. To solve a linear system, what does that mean? Where do all the solutions to any given linear equation, single equation, lie? Where do you find all of their solutions? Don't draw this down. I'm going to show you just to refresh your memory. That's no good. I needed that to work. How many solutions are on this graph right now? 0, because there's no line. Everyone agree? Okay. Now how many solutions are on that graph? Infinite. Why is it infinite, Josh? Okay. Why is it infinite? Because the line goes on forever. And every single point on that line is what? It's an X and a Y. And where can I put that X and Y? Back into this line's equation, yes? Can I put that X and Y into this line's equation? No, why? I can. Will it work? No, why? Because it's not on the line. That's for a function. That's different. But it is something. Good job. Everybody with me? Everybody good? Okay, now, what if I draw, right now, have I graphed a system of equations? Yes or no? Have I graphed a system? You've got the definition of a system right in front of you. Is that the graph of a system? How do you know? There's only one line. Now have I graphed a system? Okay. What do you know about that blue line? Is that a solution to the blue line? How do you know? Because it's on the line. Is that a solution to the blue line? Is that a solution to the blue line? Is that a solution to the red line? Why? Because it's on both lines. Understand? What if I draw a black line through there? Is that a solution to the black line? Is it a solution to the red line? Is it a solution to the blue line? Excellent. Is that point right there a solution to any of them? No. Is that point a solution to any of them? Which one? The red. Everybody understand? Okay. So you do indeed know oops, you do indeed know what it means to solve a linear equation. What does it mean? Solve a linear system. What do you have to find?
The solution.
Right? So to solve it means to find, oops, that's the wrong thickness, to find the coordinates. And how do I write out coordinates? X, Y. So you need two parts to every answer, an X and a Y, to find the coordinates that satisfy all equations in the system. Does everyone agree? This makes sense, yes? Okay. Now, in this unit, you're going to learn 3 ways to do this. Okay? One is graphing. This is with a picture. Solutions solution to lines are where in the picture? Where do they live? Where does the solution to a line live? Where does the solution to the red line live? Everywhere on the red line, right? So solutions to lines are where? On the line. Agreed? Now, think logically. If you have 2 lines that share a single point, then they must share that solution, correct? So, an intersection solves a system when we use a picture. And that's all we're going to do today. We're only going to use the pictures. These 2 are algebraic. And we use them more in reality. Because in reality, the numbers don't usually work out perfectly. Right? So when we're actually using the skills we're learning in class, in the other classes that we use them, science, chemistry, biology, math, or science, physics, chemistry, biology, math, social studies, the skills we learn in math class, we can use the graph to learn how to go further with it. Okay? Just like you learn to walk by stumbling around like a clown. And now some of you could probably are dancers and gymnasts and things, but you all started out like this. Slam. Okay? Are any of you dancers or gymnasts?
I can
Kind of do a cartwheel. Okay. So, the first thing we're going to do is we're going to solve a system with graphing. Now, I call your attention to our good friend slope-intercept form. We've just done a test on this. What is slope? Rise over run, which is our y, change of y over change of x. And b represents what? The y-intercept. Everybody cool? All right. Now, sadly, guys, I'm a bit of a doughhead, and I forgot to give you axes on your graph paper that I attached to your notes. So go ahead and sketch some on there for yourself. Sorry about that. I'm going to use a red line to graph that one and a blue line to graph that one. So let's graph it. Now, so I've got x plus y equals 4. That's not in graphing form, is it? How would I make it graphing form? Get y by itself. So x is coming over here, yeah? So y equals negative x plus 4. So So how do I graph that? Where do I start? At the y-intercept of 4. 1, 2, 3, 4. Oops, Mr. Myers. 4. Agreed? Does everyone agree? And what's its slope? -1. So if I go down 1 and over 1, I'm going to make my line all the way down, aren't I? Can I connect that line? Yes, of course I can, because I can put any number in for x and subtract 4, or add 4 to it, can't I? Yeah, they're just numbers. So I'm going to go ahead and I'm going to draw me a red line. Is everybody cool with that? Does everyone understand what I did? We've already done a test on graphing. This should not have been a surprise to even one of you. Because even if you didn't pay attention or you did badly on your test, you did some work. Is everyone cool with that? Now you know that this line goes forever that way and forever that way, yes? And any point on that line has an x and a y that will work in that equation. Are we cool with that? Okay, so right now I have an infinite amount of solutions, don't I? Because I only have one line. When I do my second line, -x plus 2y equals 2. Graph it. So what's got to move? We need y by itself. 2y equals positive x plus 2. Then what? Divide by 2, because I need y by itself. Y equals 1/2 x plus 1. How do I graph that? I go to +1, and then I do my slope, which is rise 1, run 2. Oh my good gravy. Where did that line hit? It hits, intersects right there. What is that point's coordinates? 2, 2. Does everybody understand that? Okay. Now, 2 is an x and 2 is a y, correct? If that solution is correct, that means 2, 2 should work in both equations, shouldn't it? Let's check. Is 2 plus 2 4? So it worked in the red line. Is -2 plus 2 times 2, 2. -2 plus 4, +2. It works in that line. Does everyone see how to do it? That's it. That's all we're learning today. You're gonna graph some lines. Wherever they cross, there's going to be a solution. Okay? So let's look at the second one. It's a little bit harder. Put an axis on your sheet. I'm going to use red. I'm going to use blue. You guys should be able to do this on your own already, shouldn't you? 3x minus 2y equals 12. What are you going to move first? I'd move the y, because you need y by itself and you need it positive. So y's coming here. Where's 12 going? No. 12's going over here. So I'm going to have 3x minus 12 equals 2y, correct? Now what? Pardon me? Divide by 2. 3/2 x minus 6 equals y. Can I graph that now? Where do I go? There's 2 6's on the y-axis. There's a positive and a negative. Where am I going? -6. 1, 2, 3, 4, 5, 6. And I put a dot. And what's my rise?
3,
Up 1, 2, 3.
run 2,
Which way?
right,
Right 2. And then I do it again. And I do it again. And how far could I continue this? Infinity. I'm just going to freehand this line. Because, yeah, YOLO. Exactly. Me and Drake. And then in blue, I've got 2x plus y equals 1. What needs to move? Is Vanessa right? Should I move y?
positive.
It's positive.
You should move the 2x.
I should move the 2x. Y equals negative 2x plus 1. Do I need to do any more work with that? Nope. So let's graph it. Where do I go?
You go 2 on the x.
2.
2 on the x. No, you go 1 on the
1 on the y to the y-intercept. How could you do it right here and you can't do it here? I mean, that's like saying 2 plus 2 is 4. Okay, what's 2 plus 3? I don't know. Now what's our slope? So where do I go? Down 2 and what's over? Right. Down 2 over 1. Oh my good gravy, what happened? And what is that point? Really, guys? This is what's going to kill you, telling me the coordinates of that point? 2, negative 3. The 2 is what? What? I know, right? The 2 is what? Oh, do you? Okay. Yeah. The 2 is what? The 2 is an x. Thank you, Alicia. What's the negative 3? So let's check. Is 3 times 2, what is that? 6. Negative 2 times negative 3, what is that? Positive 6. Does 6 plus 6 equals 12? Excellent. Now we check here. What's 2 times 2? 4. Plus, what's negative 3? What's 4 minus 3? 1. So it works there, so we're right. Is everybody good? Okay. What is the only new thing you learned today?
Well, if we do number 3, it'll be
That's why I'm talking right now. Up till now, what is the only new thing you learned today?
turnouts.
Is that, what linear system is? Like what?
No, you knew what a system was. It's a series of components. You knew what a linear equation was. You knew what a
I
linear
learned
system was. The only thing you learned today was intersection solves the system. If 2 graphed lines cross, that point is the solution. Everybody good? All right. Now you're going to learn something else that's new, but it's okay. All right. Whoa, good gravy. What happened there? Okay, so make your axes first. Okay, now we're going to put this one red, this one blue. We're going to do the red one first because we already know what the red one is, don't we? Graph them. Where do I go? Positive 3, 1, 2, 3, put a dot. Then what? Rise 1, run 2. Rise 1, run 2. Rise, hard to say that 5 times fast. Rise 1, run 2. Rise 1, 1, 2. Rise 1, 1, 2. I just did it. I went rise 1, 1, 2. I've become Elmer Fudd. No more bullets. Shh. Be very, very quiet. We're doing math. Get it? Because Elmer Fudd talks like that, but in Bugs Bunny he says, be very, very quiet, we're hunting rabbits. Oh, do you? Really?
I'm just so glad. Let me switch to random.
Now, I'm once again going to freehand this line. Why? YOLO. Okay, now, this blue thing is not part of grade 10. I just want to show you it because it illustrates a purpose for me later on. Okay? Here's the purpose. First of all, you need to know what that means. This notation stands for absolute value. And what that means is it is a magnitude, which we've already talked about in this class. What's the difference between a magnitude and a vector? You've all done science.
A magnitude says direction.
Other way around.
A scalar says direction.
A scalar says a distance. A vector is a distance and a direction. So a scalar is a magnitude. Okay? Magnitude is just a distance. Is my height a magnitude, which would make it a scalar, or is it a vector?
It's a magnitude.
It's a magnitude, because my height is my height no matter where I go. If I'm in space and I'm flipping around doing cartwheels, does my height stay the same? Yes, because direction doesn't matter. Everybody with me? Okay. Absolute value is a magnitude. Now here's what it means. It is just the value. Absolutely right, Bryce. Here is positive 2. Is positive 2 a vector or a magnitude? A vector or a scalar?
A vector.
It's a vector because positive in math, we've gone to the right.
Yeah.
So this is a vector. What's its value? 2. Because it takes 2 steps to get there. 2. Agreed? What's this guy's vector?
Left.
Negative 2 because we've gone to the left. What's his value? 2. Because you are still taking 2 steps. Everybody with me?
Okay.
So the absolute value is simply the distance from 0 with no positive or negative. Is everybody with me? Everybody cool? Okay. Now, if we were going to graph this and those absolute value things weren't there, we would make a table of values, or we could make a table of values, couldn't we? And we always start with x's, because x's are input, yes? Who chooses what inputs to use? You do. Anyone's will work. I always recommend you take some positives, some negatives, and 0, yes? All right, so let's go with positive 3, 0, and negative 3, correct? All right, so if I put 3 in for x, how far away is 3 from 0? 3. So the absolute value of 3 must be 3, correct? Because it's 3 away from 0. Because it's right out here, yeah? 3 steps. Agreed? Okay. Now I'm going to put in 0. How far is 0 from 0? 0, because it's right there. How far is negative 3 from 0? 3. Now, do I have some points? Now I can graph them, can't I? First point is 3, 3. 1, 2, 3, 1, 2, 3. Cool? Agreed? Next point is 0, 0. Agreed? What's the third point? Negative 3 and then up 3. What? What the heck kind of graph does that make? I go over 1, up 1, over 1, up 1. How long will that go this way? Forever.
But it only needs to get to 6.
But it only needs to get to 6. How long will it go this way? Same thing. Making this shape. It's not a parabola. It's the graph of an absolute value function. Now, guys, what's the one new thing you learned today? Everywhere on a graph, everywhere that there is, holy crap, we did like 30 seconds ago we did this. Everywhere there's an intersection, what do you have? The solution. How many intersections do you have here? Two. So how many solutions do you have? Two. That's the point. Understand? So this guy is 6, 6. Does that work? Put in 6 for x. What's the absolute value of 6? 6, because it's 6 steps away from 0. Does 6 equal 6? So it works. What's half of 6? What's 3 plus 3? 6. Does 6 equal 6? So it works. Now come over here. What's that? Negative 2, 2, correct? X is negative 2. What's the absolute value of negative 2? 2. So it works, correct? What's half of 2? Half of negative 2, sorry. Negative 1. What's negative 1 plus 3? Positive 2. So does it work there? So there you go. That's the point I'm trying to make with this. I chose absolute value because it's the easiest thing to show you that you can have more than one intersection. Understand? What if in grade 11 you'll be graphing stuff like this? And then you'll have a curve that comes in like this. How many solutions does that have? 4. Understand? Everywhere a graphed line crosses, you have a solution. That's the lesson today, no matter what the shape is. In university, you'll be graphing things like this. Solution, solution, solution. Picking up what I'm putting down? Doesn't matter what it looks like. And again, the basic skill is here. Graph 2 lines. Anywhere they touch, there's your answer. Doesn't matter what the graphs look like. If they cross, you have a solution. Bryce.
On an exam, would they ask you for all of them, or would they ask you for one, a solution?
For you guys in grade 10,
Well, I meant in general.
it's always going to be 2 lines.
Well, yeah, I know, but in general, would they ask you for all solutions on that? Like in grade 11 or whatever?
For something like this,
Yeah.
depends on the question, because sometimes the solutions can't exist. For example, if this was time, there couldn't be a negative, could there? So if you're getting away from us, but that's okay. If the Cartesian plane were here, none of these negative solutions could exist, could they?
I see.
Right? Or if we were jumping out of a plane, we couldn't go below 0. We're not sinking into the ground. We splat. Understand? So we couldn't have this negative solution. Picking up what I'm putting down? So in grade 11, in math class, there's 4 solutions. But in physics, there can't be 4, because you can't have negative time, you can't have negative heights, things like that. You understand? That's why you learn the skills in math class and then apply it elsewhere. Got it? All right. Now listen, Miss Varnes will be here any minute. Please do just those questions. It's only 5 questions. Here is a pile of graph paper. If you wish to, right there on Vanessa's old desk, if you would like graph paper. Now listen to me and listen to me closely.
All of it.
You guys stunk on your last test on graphing. Here is a whole page with graphing. Would you be wise to maybe do a little bit more than those 5 that I asked you to do to get the extra practice?
Myers, it was like, I think it was 7 or 8 questions where I put like the positive, we're supposed to be negative.
I know.
Negative, we're supposed to be
I'm well aware. I mark it.